It's you. This predicament is harder than I thought. There's a lot of variables in play here that makes the equation hard to solve. I wonder. Why is this so hard to solve? I don't get it! This is possible. I'm about to give up.
Why even is this a problem? Why is it my problem
This is
first of all?
impossible. I can't.
So we are going to integrate over the curve c of y to the third ds.
Wait. Eureka! My doubts and worries have been cleared. I've been ignoring this part all along? No, this can't be it. But it fits the puzzle perfectly. It is the missing piece. Hello there. So my name is Chavez Isaac P. Ferreira, and I do hope that you get at least entertained by that short skit at the beginning of the video. It was just for fun. So now I just want to get started into actually solving the problem. I'm gonna show you how do I solve it and explain it to you on the way. And yeah, I do hope that you learn something by the end of this video. So yeah, let's get started. Okay. Hold on. Let's break this down a bit. So before we solve this problem, of course, you have to write down the actual problem. The problem that we're trying to solve is x squared over 25 plus y squared over 16 equals 1. So from this problem, we can already deduce a squared and b squared. So a squared and b squared is equals to 25 and 16. Let's write that down. And we can already get a and b, which is 25. What's the square root of 25? It's 5. What's the square root of 16? It's 4. So now we have determined our ab squared and ab. So now let's try to get c. So the formula for trying to solve for c is quite easy. So it's square root of a squared minus b squared. So just substitute the given terms, which is 25 or 16. So 25 minus 16, you get the answer of 9. And what's the square root of 9, you say? It's 3. So now we have c. Now since we have c, we can now solve for the center. Sorry for the noise outside. I can't really do anything about that. I really can't do anything about that. So yeah, sorry about that. So now we have ab squared and abc. We can try to solve for the things needed to graph the ellipse. So from this problem, we can already determine our center to be at 0, 0. Our vertices, though, we have to solve it. Oh, sorry about that. Vertices or vertices. So to solve for the vertices or the vertices, I'm just gonna write v just to save space. The formula for the vertices is quite simple. It's plus minus a and 0. So just substitute the needed variable. So a is 5 and 0 and negative 5 and 0. I'm just gonna write it down here. So now we have the vertices. Now we have to search for the foci or the foci. So the formula for the foci or the foci is plus minus c and 0. So just substitute it. We have c, 3 and 0, and negative 3 and 0. Just put this here. So the next thing we have to solve for now is the minor axis. So I'm gonna put that here. So the minor axis, or the formula for the minor axis, is 0 plus minus b. So basically just substitute b. So 0 and b, and 0 and negative 4. Just gonna put this here, 0 and 4, and 0 and negative 4. The next thing you have to solve for now is the directrix. So directrix can be easily quite solved by the formula of x equals plus minus a squared over c. I'm gonna substitute it. A squared is 25 and over 3. Now we can, of course, I'm gonna convert it to mixed number, which is 3 times 8 is 24, so I get 8. And 3 times 8, 24 plus 1, 25. So 8 over 1/3. So our directrix is 8 and 1/3 and negative 8 and 1/3. There we go. Now our directrix is solved. We have to solve the latera recta or the latus rectum. I'm gonna solve that down here since it's gonna be quite lengthy. So LR. So to solve for the latus rectum or the latera recta, you have to use the formula of negative c plus minus b squared over a. So you have to use this formula. So negative c is negative, will become negative 3, and plus b squared is 16 over 5, and again negative 3, but this time that's negative. And the next formula that we have to use is positive c plus minus b squared over a. So 3 plus 16 over 5 and negative, oh, sorry about this, that's the wrong one. 3 negative 16 over 5. 3 and negative 16 over 5. So now we have solved for the latera recta. So we have all the things needed to graph this. You have the center, the vertices, the foci, the minor axis, the directrix, and the latera recta. So now let us move over to graphing this thing. Okay, so I'm gonna explain to you what I did and what each point of the graph represents. So first of all, let's start with the easiest one. What's the color? Let's go with red. So this is currently the center. 0, 0 is our center. Now while our vertices is this: negative 5 and 0 and 5 and 0. Negative 3 and 0 is our focus, and 3 and 0 is the other focus. Okay, and then the next one is our minor axis. Our minor axis is at 0 and negative 4. So this is one of them, and the other one is this one. And the next thing is the directrix, which I converted, by the way. You have to convert it into decimal before you can graph it, so it becomes easier to graph. It's negative 8.3 and 0 is one of our directrix, and 8.3 and 0, it's the other directrix. So the next thing that we're to find is the latera recta or latus rectum. This is it. This is the 4 latera recta that we solved. There we go, and there we go. So now you can notice by this is that there's gonna be an ugly ellipse. Please spare it. I am so sorry for how ugly this is, but this is gonna be the best that I can do, okay? So you can notice from this that our ellipse is indeed, we can prove that our ellipse is indeed horizontal by graphing it. Anyways, that is gonna be my video or on how to solve this problem or how do you solve this problem. So yeah, thank you for watching and yeah, have a nice day. So I do hope that you learned something from that video. Even if it's just a little, at least you've learned something. So that will be it for me. Goodbye.